Myself, Deshmukh Sachin, working as assistant professor in the Department of Civil Engineering of Walchand Institute of Technology, Solapur. Today we are going to solve the problems on viscosity and compressibility, which are most important properties of fluid. So at the end of this topic, you can able to solve any problem on viscosity and compressibility. Let us start the solving problems, but before that, you just recall the definition of compressibility as well as viscosity. A 100 Newton rectangular solid block slides down a 30-degree inclined plane. The plane is lubricated by 3 millimeter thick film of oil whose relative density is 0.92. Relative density, it is a specific gravity. And viscosity is 7 poise. The contact area is 0.4 meter square. Estimate the terminal velocity of the block. Immediately you have to draw the figure. This is the block which is sliding down, having the angle 30 degree. Its weight is acting normally. Velocity is going on the sliding side. You can say on the sloping side. Shear stress is, you can see, which is opposite to this velocity. As per the direction which I have given to you before also, when we are going to solve any problem, we have to write the data given in the problem. So weight 100 Newton, relative density, that is specific gravity, theta angle, that is 30 degree, mu dynamic viscosity 7.7 poise, that will convert now. Area is 0.4 meter square and the thickness of the film is 3 millimeter. Again we will convert it. Now we know the particular equation regarding dynamic viscosity, that is tau is equal to mu into du by dy, or mu is equal to tau upon du by dy. Tau is shear stress, mu is dynamic viscosity, du is the velocity and dy is the thickness. Okay. Now when again come to this figure, we have to resolve these in two directions. I told you, in you can say horizontal as well as vertical direction, this particular weight. So w sine theta we have to take into account, minus tau, that is shear stress, into area is equal to 0, or in word we can say at the terminal velocity the sum of the forces acting on the block in the direction of motion is equal to 0. It is w sine theta is equal to tau a. W sine theta minus tau a is equal to 0, where tau is shear stress, area is area of the block. Now mu is 7 poise is given to you. We will convert it into Pascal second, that is 1 upon 10. We have to multiply, that is 7 upon 10 is Pascal second. H, that is 3 millimeter, that is 3 into 10 to the power minus 3 meter, that is the thickness of the oil film. Dy, which we are going to take, area is 0.4 meter square. Substituting these values, W is 100 Newton, sine 30 degree, minus shear stress is 7 by 10, okay, 7 by 10, or you can say 0.7 V upon, you can say, that is dy, it is 3 into 10 to the power minus 3, 3 into 10 to the power minus 3 into area, it is 0.4 meter square, 0.4 meter square. Substituting these values, 0.7 into du, it is nothing but the velocity. Here I have taken velocity v. You may write, but at the end you have to convert it into terminal velocity, that is v. So substituting all the values, we will get v is equal to 0.714 meter per second. Each and every problem you have to see very carefully, you have to write the data very carefully and recall the formula that which you are knowing related to this particular definition and topic. Let us move to another one. The velocity distribution near the solid wall at a section in a laminar flow is given as u is equal to 5 sine into bracket 5 pi y bracket complete for y which is less than equal to 0.1 meter. Compute the shear stress at the section. Whenever some new words are coming, laminar flow, Okay, you have to recall there are three types of flows. I'm just taking your revision. Laminar flow, there are three types of important flow: laminar, transitional, and turbulent. Okay, which are depending on totally the Reynolds number. Now here the three conditions are there. When y is equal to 0, y is equal to 0.5, and y is equal to 0.1. We have to calculate for these three, and the dynamic viscosity of the fluid is given as 5 poise. Okay, so 5 poise, just now we are how we are converted, that is 7 poise, 7 upon 10 Pascal second. Similarly, 5 poise, 5 upon 10 Pascal second. U is already given, that is 5 sine into bracket 5 pi y. This is a velocity given to us. Okay, and du by dy, that is 5 into 5 pi cos. Okay, that we are the derivation of this du by dy, it is 5 into 5 pi, instead of sine it is cos. Okay, into bracket 5 pi y as it is. We are taking the derivative, that is du by dy, this particular with respect to y. So it is du by dy is 5 into 5 cos into bracket 5 pi y. This is the only important step in this problem. Remaining everything that we you have to put up in the equation only. So shear stress tau, which is our basic important equation, shear stress tau is equal to mu into du by dy. So mu is 5 by 10, and this is 5 into 5, 25 pi cos into bracket 5 pi y. This is your answer. Is your answer. See, what is the important step in this? That is a derivative. That is du by dy for this particular velocity. Similarly, we have to put the values of y is equal to 0, y is equal to 0.05, and y is equal to 0.1. Similar calculations are there. Okay, for y we are getting 39.27 Newton per meter square, all Pascal. Then for 0.05 it is 27.76, and it is for 39.26. For your practice, we have taken three conditions so that you can do the calculation very fast. We'll go to next problem. The space between two quadratic plate is fixed or is filled by oil. The length of each plate is 720 millimeter. The thickness of the oil film is 15 millimeter. The upper plate that is moving with velocity of 3 meter per second needs a pulling force of 120 Newton to keep the constant velocity. We have to calculate dynamic viscosity as well as kinematic viscosity. Okay, recall your memory for kinematic viscosity. The data given: force 120, specific gravity 0.95, velocity 3 meter per second, thickness of the oil film 15 millimeter, length it is 720 side, that is, and area it is, we calculated 0.5184. We know tau is equal to force upon area. Calculate this one. Then from Newton's law of viscosity, that the equation that we are knowing, shear stress is equal to mu into du by dy. So dynamic viscosity, mu is equal to tau upon du by dy. We get mu is equal to 1.16 Newton second per meter square. Just remember this particular unit, Newton second per meter square. And what is the kinematic viscosity? Kinematic viscosity, it is a ratio of dynamic viscosity upon the mass density. So 950.95 is the density given to you, multiplied by 1000, that is a density of water you have taken, that is, it is 950. So 1.16 upon 950, it is 0.00 meter square per second. So meter square per second, it is a unit of kinematic viscosity, please remember. Now we'll go for some problems of compressibility. When the pressure of a liquid is increased from 4.5 mn to mn square to 8 mn per meter square, its volume is found to decrease by 0.08%. What is the bulk modulus of elasticity? Write down the initial pressure, final pressure, increase in the pressure dp and decrease in the volume. As pressure is increases, volume is going to decrease here. So we know the equation for the bulk modulus of elasticity, K is equal to dp upon minus dv upon v. It is a change in the pressure, increase in the pressure, and it is you can say velocity. Okay, so you can see it is put the values 3.5 into 10 to the power 6, and the change in the volume we will get 4.373 into 10 to the power 9 Newton per meter cube. I will convert directly into GN, that is giganewton per meter cube. Then similarly, second problem is same. When a pressure of 22.5 mn per meter square is applied to 130 liters of liquid, it is decreased by 1.2 liters. Find the bulk modulus of elasticity. These are the data, and we have to put in the in this particular equation, and you can find in the find the bulk modulus of elasticity. Let us see some review questions are there. Kinematic viscosity, how we can convert, what is the unit of kinematic viscosity. Poise, Poise is the unit of which particular property, Stoke, etc. Just see the answers. Kinematic viscosity, it is represented. Poise, dynamic viscosity. Stoke, kinematic viscosity. Compressibility, meter square per Newton, and this Newton second per meter square is 10 Poise. Just go through this some reference books. Thank you.